Good morning. I am Devasena. In this lecture, we are going to discuss about electromagnetic waves, and in detail, we are going to discuss about light wave. This topic is present in the subject Basics of Communication. There is the fundamental topic that has to be known in the communication field. Electromagnetic waves. Electromagnetic waves are waves that can travel through a vacuum like in space. Examples of electromagnetic waves include radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Radio waves have the lowest energy and frequency and the longest wavelength. The electrical and magnetic fields continuously induce each other. An electromagnetic wave transports its energy through a vacuum at a speed of 3 into 10 power 8 meter per second. That is a speed value commonly represented by the symbol c. Matter is not needed for this to occur. This kind of wave is called an electromagnetic wave, and light is such a wave. Let us see the electric field magnetic field representation in the form of graph. This is the representation of the electric field magnetic field. The electric field is represented in a blue color waveform, and magnetic field is represented in red color waveform. This is the overview of electric field and magnetic field representation. Let us see the sources of electromagnetic waves. An electromagnetic wave can be created by accelerating charges. Moving charges back and forth will produce oscillating electric and magnetic fields, and these travel at the speed of light. Accelerated electrical charges are the sources of all electromagnetic waves. The energy source is whatever is doing the accelerating. Electromagnetic waves consist of both electric and magnetic field waves. This is the representation of the electric field wave and magnetic field wave. Here, the electric field wave is represented in red color and magnetic field wave is represented in blue color. This is indicated here. These waves oscillate in perpendicular planes with respect to each other, and they are in phase. The creation of all electromagnetic waves begins with an oscillating charged particle which creates oscillating electric and magnetic fields. Can electromagnetic waves travel through matter? You can see light from the moon, distant stars and galaxies, because light is an electromagnetic wave. Electromagnetic waves are waves that can travel through matter or through empty space. In empty space, light travels at a speed of about 300,000 kilometers per second. Difference between electromagnetic waves and mechanical waves. Electromagnetic waves are waves that have no medium to travel, whereas mechanical waves need a medium for its transmission. Electromagnetic waves travel in a vacuum, whereas mechanical waves do not. While an electromagnetic wave is called just a disturbance, a mechanical wave is considered a periodic disturbance. Mechanical wave, light wave representation is shown here. This is the representation of the light wave and mechanical wave. As we already know that light wave is an example for the electromagnetic wave. Here we are having the electric field as well as the magnetic field in the light wave. And the mechanical wave is also represented here. Electromagnetic wave, that is light wave traveling representation. In this representation, we are seeing that light waves are traveling in space. Let us see light wave prism representation. We know that when a white color wave hits in a prism means it emits light waves in the form of wave. This is represented in this diagram. Let's start discussing the light wave. Light, viewed classically, is a transverse electromagnetic wave. The underlying oscillation, that is, in this case, oscillating electric and magnetic fields, is along directions perpendicular to the direction of propagation. Light is said to be linearly polarized if its oscillation is confined to one direction. The direction of the oscillation of the electric field is defined as the direction of the polarization. Most light sources in nature emit unpolarized light. That is, light consists of many wave trains whose directions of oscillations are completely random. Polarized light wave. Light may be polarized by passing it through a sheet of commercial material called Polaroid, invented by E.H. Land in 1938. A sheet of Polaroid transmits only the component of light polarized along a particular direction and absorbs the component perpendicular to that direction. Polarization. Polarization in physics is defined as a phenomenon caused due to the wave nature of electromagnetic radiation. Sunlight travels through the vacuum to reach the earth, which is an example of an electromagnetic wave. These waves are called electromagnetic waves because they form when an electric field interacts with a magnetic field. Let us see polarization. Polarization is the property of the wave that can oscillate with more than one direction. A light wave that is vibrating in more than one plane is referred to as unpolarized light. The process of transforming unpolarized light into polarized light is known as polarization of light. Polarization representation is shown here. This is the representation of the polarization process. Non-polarized light wave is passed to the Polaroid, and from that Polaroid we are obtaining polarized light wave. This is indicated here. Horizontally polarized light wave. If the oscillations of the light wave are in a horizontal plane, then the light wave is said to be horizontally polarized. This is the representation of the horizontally polarized light wave. Here, the polarization is in horizontal plane. This is indicated in this graph. Vertically polarized light wave. If the oscillations of the light wave are in a vertical plane, then the light wave is said to be vertically polarized light wave. This is the representation of the vertically polarized light wave. Here, the polarization takes place in the vertical direction. This is indicated in this graph. Light wave in the form of electromagnetic wave representation. We know that light wave is an example of electromagnetic wave. The electromagnetic wave comprises of electric field and the magnetic field. This electric field and magnetic field is indicated in this graph, that is in the form of light wave. Colored light waves. This is the representation of colored light waves. Another representation of the colored light waves is shown here. Flashing light representation is shown here. This is the representation of flashing lights. Another representation of flashing lights. Light wave enters human eye representation is shown here. This is the representation how the light wave enters the human eye and how it hits the optical nerve, that is the focal point. How a normal eye focuses light, a small representation. Light emitted or reflected from objects enters the human eye. In the human eye, we are having normal cornea that refracts light and protects the eye, and the light waves enters the lens that are present in our eye and it hits the focus point in the eye. Retina is placed at the backside of the eye. Light sensitive cells create nerve impulses in the retina, and this nerve impulses is sent through an optic nerve. That is, optic nerve sends nerve impulses to the brain for interpretation. Let us see how our eye works. A small representation of the human eye function. Light wave enters your eye through the lens. Our iris dilates, changing the size of our pupil. The size depends on how much light our pupil needs to let in. Then our lens sends the light to the back of our eye, but the image is flipped upside down. This is indicated here. Our retina sends the image as an electrical signal to our brain, and our brain flips it right side up. This representation is shown here. Processing in brain, a small animation. This is an animation of a visual processing, how it takes place. Light wave enters our human eye. It is being processed in the brain in the occipital lobe. This is represented here. Optical nerve processing representation is shown here. This is the representation right visual field and left visual field are passes to the human eyes. From that it is passed to the brain. In the brain we are having occipital lobe. The occipital lobe is responsible for human vision. Here primary visual cortex is indicated. Here the visual processing takes place and feedback is given to our eye. A representation of an human eye is shown here. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video to your friends.